Hello everyone. So in this video I'm going to discuss JEE Mains 2024 January 29 Shift 1. So in this paper there are some questions which are quite calculative. So let us see. Now the first question is de Broglie wavelength of electron and proton are equal. Then the ratio of kinetic energy of the electron and proton. A very straightforward question. If de Broglie's wavelength are same, so if lambda E is equals to lambda P, we can say the momentum of E will be same as the momentum of the proton. If momentum are same, we have to find the ratio of the kinetic energy, and we know that P square by 2m is the kinetic energy. So if I square this equation, we will get K, you can say 2m EKE will be equals to 2mp Kp. Now from this we can get the ratio of the kinetic energy. So Ke upon Kp will be mp upon me, and we know this ratio, it is around 1836. So that is the answer. A very straightforward question. Next, if an object is having same weight at the same distance above and below the surface of the earth, find its distance from the surface of the earth. Now in this question, it is not mentioned whether that distance is comparable to the radius or not. So what we have to do, we have to use the general formula, and the general formula for the altitude is G will be G divided by 1 plus h by r square. So we are going to use this formula for the altitude. And this G is same as the G at the depth, which is 1 minus h by r. Now from here we have to calculate r. Sorry, we have to calculate h. Now this G will get eliminated. So we have 1 plus h by r square will be equals to times 1 minus h by r is equals to 1. Let us simplify this. So we have 1 minus h square by r square times 1 plus h by r, that is 1. So 1 minus h square by r square plus h by r minus h cube by r cube is equals to 1. So this 1 will get eliminated. So we can again take h by r common. So we have minus h by r plus 1 minus h square by r square equals to 0. Now let us take the LCM. So we have, we can say minus rh plus r square minus h square should be 0, or we can say h square plus rh minus r square should be 0. Now it's a quadratic equation, so we can find the value of h will be minus r plus minus root b, that will be r square plus 4r square divided by 2. So this comes out to be root 5 minus 1 by 2 times r. Okay, so option D is the right answer. Again, it's not like you can say a bit calculation, but the question is quite like typical. We have covered the same question in class. Next question is from the error analysis. Now, voltage applied across a resistance R is 200 plus minus 5 volt, and current in the resistance is 20 plus minus 0.2 ampere. Then find the percentage error in the resistance. So we know that resistance is V by I. So to find the percentage error, the relative error in R will be sum of the relative error in voltage and the current. Now delta I is 0.2 and I is 20 and delta V is 5 and R is and V is 200. Now that is the relative error in the resistance. If I multiply this with 100, we will get the percentage error. So this comes out to be how much? So it will be 2.5 plus 1. So 3.5% is the answer. Again, very basic question. Okay, next, an object is moving with centripetal acceleration of constant magnitude in a curved path. If the ratio of the radius of curvature at the two different points is given by 3:2, then find the ratio of speeds at these points. Again, formula based question. Centripetal acceleration is v square by r. So, and the acceleration is same. So we can say v1 square by r1 will be equals to v2 square by r2, and v1 by v2 will be square root of r1 by r2, and r1 by r2 is given as 3:2. So that is the answer. Okay, again formula based question. If a body of mass 100 kilograms travel 10 meters before coming to rest, if mu is 0.4, work done by the friction. Very easy question. There is a block which is having a displacement of 10 meters. and when it is moving there will be a kinetic friction, right? That will be mu k n, where n is mg is 1000, right? So what is the work done by the frictional force? It will be minus mu k n times the displacement. So mu will be mu is zero point 0.4 and n is 1000. I'm taking g as 10. It is also given in the question. Multiplied with 10. So it comes out to be minus 4000 joules. Now that is the answer. Next, a solid sphere of radius 4a units is placed with its center at the origin. Two charges minus 2q at minus 5a comma 0 and plus 5q at 3a comma 0 is placed. If the flux through the sphere is x cube by epsilon naught, find x. Okay, let me draw this the diagram for this question. So we have given a sphere and its radius is 4a. So radius is 4a unit, and its center is located at the origin. So this is 0 comma 0, and there is a charge of 5q which is placed at 3a comma 0, and there is a charge of minus 2q which is placed somewhere here, that is minus 5a comma 0, and this is minus 2q, and we need to find the flux through this sphere. A very basic question. So by Gauss's law we can say the flux will be q enclosed divided by epsilon naught, and whatever charge which the charge which is enclosed by the Gaussian surface, I am considering this sphere as my Gaussian surface. If this is my Gaussian surface, then the charge enclosed in this is nothing but 5q, right, by epsilon naught. So x will be nothing but 5. So that is the answer. Next, consider two statements assuming density of water to be constant. Statement 1, so basically we have to check which statement is true and which statement is false. Statement 1 is the capillary tube is first dipped in hot water and then dipped in cold water. The rise in is higher in hot water. Okay, right. So the density is not changing, and we know that the height of ascent is 2s cos theta divided by rho rg. So in this, density is constant, and we know one thing: if we increase the temperature of water, then the surface tension decreases. So as temperature increases, surface tension decreases. So in this question, I'm not considering the thermal expansion of the tube. So I'm only considering the effect of temperature on surface tension. So, so in hot water, since S is less, so we can say, so height in hot water will be, height of ascent will be less, you can say, in cold water, right? So in the first statement 1, a capillary tube is first dipped in hot water and then dipped in cold water. The rise is higher in hot water. That is incorrect. So statement 1 is incorrect. Statement 2, capillary tube is first dipped in cold water and then in hot water. The rise is higher in cold water. So this one is correct. So for statement 1 is false. Statement 2 is true. Right? Next. This question is from current electricity. Again, very basic question. Current is given to us as a function of time, and we have to find how much charge has been passed through the conductor in 20 seconds. So I is given as 20 plus 3 times t. So we can write I as dq by dt. So this will be 20 plus 3t times dt. Now we can integrate this. Now the limit is from 0 to 20 seconds. So this will be 20t plus 3t square by 2, and let us put the limit from 0 to 20. So this will be 400 plus 3 by 2 times 400, right? So this comes out to be 200. So it will be 1000 coulomb. So that is the answer. Okay, next, a stationary hydrogen atom de-excites from first excited state to the ground state. Find the recoil speed of the hydrogen atom up to the nearest integer value. So we have given first excited state. So first excited state is nothing but n equals to 2, and this is the ground state, n equals to 1. Now the electron is coming down from a higher energy level to a lower energy level. So when it does, it will release a photon of energy, let us say hc by lambda, right? And we need to find the recoil speed of the hydrogen atom. So if there is an hydrogen atom, and suppose if it is at rest, if it releases a photon, by momentum conservation for this system, we can say the momentum, the magnitude of the momentum of the atom, recoiling atom, will be same as the momentum of the photon. So if you're able to find the momentum of the photon, we can find the momentum of the atom, and then by dividing the momentum by the mass of the atom, we'll get uh, the recoil speed. Okay, right. So first let us calculate the lambda. So energy, so delta E, the energy of the photon will be 13.6, 1 minus 1 by 4. So this comes out to be 10.2 electron volt. And so 10.2 times 1.6 into 10 raised to minus 19, it is in joules. That will be equals to hc by lambda, where h by lambda is the momentum, right? Momentum of the photon. Divided this by c, so this comes out to be momentum. So if I divide this momentum by, this momentum is nothing but mass of the hydrogen atom, and it is given as 1.8 into 10 raised to minus 27 times the recoil speed. Okay, so can you see here we have 1.6, this is 1.8, and this is nearly 3. Yeah, so if you simplify this, V comes out to be nearly equals to 3 meters per second. So that should be the answer, right? Next, a wire of resistance 16 ohms is bent to form a square, and a battery of EMF 9 volt at an internal resistance 1 ohms is connected across the side of the square, and 4 microfarad capacitor is connected across one of the diagonal. Okay, let me show you the diagram. So I have a square made with a uniform wire. So if it is a uniform wire and the total resistance of the wire is 16 ohms, then each side will be having 4 ohms resistance. And we have connected a battery which is having an internal resistance of 1 ohms, and the EMF is 9 volt, and we have connected a capacitor between like along the diagonal, right, like this, and it is a 4 microfarad capacitor, and we need to find the energy stored in the capacitor. So in steady state, there will be no current in the capacitor branch. So if the current I is coming, some part will go to these 3 resistors which are in series, and say I2 will go to this resistor. So in steady state, I can say this is the circuit diagram. So we have 12 ohms and 4 ohms in parallel, and there is a battery. Internal resistance is 1 ohms. This is 9 volts. So 12 times 4 divided by 12 plus 4 will be the equivalent resistance of these two resistors in parallel. So that will be 16. So 4. So this will be 3 ohms. So this will become 3 plus 1. So we can say 3 plus 1. So this will be 4 ohms, and we have 9 volt battery. So the current supplied by the battery will be V by R. So that is the current. Now let us divide this current in these two branches. So here the current will be will divide in the inverse ratio of the resistance. So here it will be 9 by 4 times 4 divided by 16. So this comes out to be 9 by 16, right? So I can say in this branch the current is 9 by 16. So 9 by 16 times the resistance will be the potential drop across the capacitor. So V across the capacitor will be 9 by 16 times 8. So this will be 9 by 2. So the charge on the this is the potential. So energy stored in the capacitor will be half CV square. C is 4 microfarad, and it will be 81 by 4. So it comes out to be 40.5 microjoules, right? So based on this data, that should be the answer, right? Half CV square, that we have to calculate. Now let's see the next question. A particle is executing simple harmonic motion with an amplitude A. Find the ratio of total energy to the kinetic energy at x equals to A by 3. Again, formula based question. Kinetic energy is given as half k A square minus x square, and total energy is given as half k A square, right? So this is the total energy. Now we have to find the ratio of these two, and at x equals to A by 3, this will become half k A by 3. If I substitute, it becomes 8 by 9 A square. So total kinetic energy divided by the kinetic energy will be 9 by 8. So that should be the answer. Next, a cylinder on an incline of 60-degree rolls down with an acceleration x by root 3. Find x. So we know what is the acceleration down the incline if there is a body which is rolling down. So acceleration will be given by g sine theta upon 1 plus k square by r square, and the k square by r square value for solid cylinder. So I'm taking a solid cylinder is 1 by 2. So this will become 10 sine 60 will be root 3 by 2 divided by 1 plus 1 by 2. So this will be 5 root 3 divided by 3 by 2. So it comes out to be 10 by root 3. So 10 is the answer. Yes. Next is the question from thermodynamics. So we have to find the work done in the process ABC. And since it is like this, right? ABC. So the direction is given to us ABC. So it's a cyclic process and it's a clockwise cycle. So work done will be positive. And what we have given pressure in dynes per centimeter square, and the volume is given in meter cube. Now what is the area of this? So area will be half. Can you see the values? So this is 7 and this is 3 and this is 4,000 and this pressure is 8,000 in CGS unit. So work half base is 4, which is in meter cube, right? Multiplied with the height, which is 4,000. Let me convert this dyne per centimeter square in the SI unit. So one dyne is 10 raised to power minus 5 Newton, and 1 centimeter is 10 raised to power minus 2 meters. So this should be in SI units. So this comes out to be 2. So we have 2 times 4,000 times 10 raised to power minus 1. So answer is 8,000 joules. So that is the work done. Next, so potential energy of a particle is given by this. This is the function. Find the force on the particle. So if you remember, we have done this. It's based on the partial derivative concept. So the conservative force will be given by minus del u by del x I cap minus del u by del y j cap minus del u by del z k cap. Now we need to find the force at 1, 2, 1. So if I find the del u by del x, it comes out to be plus 8x, right? And del u by del y will be 1 and del u by del z will be 1. So force will be minus 8x I cap minus j cap minus k cap. If I substitute x as 1, because we have to find the force at 1, 2, 1, it will be minus 8 I cap minus j cap minus k cap. So option B is the right answer. Again, very easy question. A capacitor having capacitance 100 microfarad is charged with a potential of 12 volts, is connected to an inductor of 10 millihenry. Find the maximum current through the inductor. So this question is from LC oscillation. And in LC oscillation, the maximum current will be given by 1 by root LC, which is the angular frequency of oscillation, times the maximum charge on the capacitor. So maximum charge will be what? We have 100 microfarad times 12 divided by root LC. L is given as 10 millihenry, C is given as 100 microfarad. So from here, this milli will get cancelled out and we have 10 raised to power 3 into 10 raised to power 2 times mu times 12. So this comes out to be how much? 1.2 ampere, right? Again, very basic question. Consider a series of steps as shown. Okay, so basically, let me draw the diagram first. So here we have given a series of steps. And the length and the height are same, right? So this is 0.5, this is 0.5 meter, like this. A ball is thrown from O. Find the minimum speed to directly jump to 5th step. So 1, 2, 3, 4, and 5, right? So the coordinate of this particular point where we want to land this ball will be 2.5, 2.5. So okay, so when we know 2 points on the trajectory, one is, let us say, the origin, other is 2.5, 2.5, we can apply equation of trajectory to find the minimum speed. So we have y is equals to x tan theta minus g x square upon 2 u square cos square theta. So if I substitute 2.5 comma 2.5, so 2.5 is equals to 2.5 tan theta minus, I'm taking g as 10, so 2.5 square divided by 2 u square cos square theta. So 1 2.5 will get cancelled out, and this will be 1 equals to tan theta minus 25 by 2 u square cos square theta, right? Now from this equation, now I have u as a function of theta, right? So let us simplify this. So I can say 25 by 2 u square cos square theta can be written as tan theta minus 1. And I can say 2 u square cos square theta can be written as 25 divided by tan theta minus 1, and u square will be equals to 25 secant square theta by 2 tan theta minus 1. Now we have u square as a function of theta. Now we can use maximum minimum. So let us do that. So if I differentiate the right hand side, basically this is the area of interest. So let us find this, the differentiation of this. So d by d theta of secant square theta upon tan theta minus 1. So this comes out to be 2 secant theta square tan theta. So tan theta minus 1. So minus secant square theta secant square theta divided by tan theta minus 1 square. So I've applied quotient rule. So from these two, from the first and the second term, secant square theta will be, we can take it as common. So we can say 2 tan square theta minus 2 minus secant square theta should be 0, right? So if that is the case, so 2 tan square theta minus 2 and secant square theta can be written as 1 plus tan square theta. So this comes out to be, so minus, yes, so we have tan square theta minus 2 minus 1 equals to 0. So tan square theta comes out to be 3. Can you see? Let me again check. Yeah. So tan theta comes out to be root 3. So if I substitute tan theta is root 3 in this equation, so 25 by 2, so we have 1 plus 3 divided by, and this will be root 3 minus 1. Okay, so if I simplify this, this will be 2. So we have 50, and then it will be root 3 plus 1 divided by 2, right? 50 and root 3 plus 1 divide. So I have rationalized the denominator. So this will be 25 root 3. Here we have 25 root 3 plus 1. And if I take the square root of that, the answer comes out to be 5 times root of root 3 plus 1. Now let us see the another question. So in a convex mirror having a radius of curvature 30 centimeter, the height of the image is half the height of the object. What will be the object distance? So we know that in convex mirror, we have a virtual and direct image and diminished image. So magnification will be positive. So it will be 1 by 2, and we know that it is minus v by u. So from here we can say v is equals to minus u by 2. So by using a mirror formula, so 1 by minus u by 2 plus 1 by u is equals to 1 by 15, because radius of curvature is 30. So from here minus 1 by u comes out to be 15, and u comes out to be minus 15 centimeters. So at a distance of 15 centimeter from the pole, we have to place the object. Right, again very basic question. So if you have seen the questions, most of the questions were easy, and it is very easy to score plus 80 marks in this paper. So wish you all the best for your attempt.